A palindrome reads the same forwards and backwards, like the list 1, 2, 2, 1. To check a linked list for this, we combine two tricks we already know. Find the middle with slow and fast pointers, then reverse the second half, and finally compare it against the first half node by node. Here is the plan. First, we use the slow and fast pointer trick to reach the middle of the list. Then we reverse the second half in place, flipping its links backward. Now we have the first half going forward and the second half going backward, both starting from the two ends. We walk them together, comparing values. If every pair matches until we run out, the list is a palindrome. If any pair differs, it is not. First, slow and fast, find the middle. Then, starting from the middle, we reverse the second half so Prev becomes its new head. Finally, left walks forward from the original head and right walks the reversed half. If any pair of values differs, we return false. If they all match, we return true. Let's test a palindrome list and a non-palindrome in a live editor. A node holds a value and a link to the next node. Slow and fast pointers walk until slow reaches the middle. Reverse the second half in place so Prev becomes its new head. Walk both halves together and compare. All equal means a palindrome. Now let's test it and hit run. There it is. 1, 2, 2, 1 reads the same both ways, so true. 1, 2, 3 does not, so false. Here is the shape. Find the middle with slow and fast. Reverse the second half. Then walk left from the head and right from the reversed half, comparing values. Any mismatch returns false, and matching all the way returns true. Each phase, finding the middle, reversing the half, and comparing is a linear walk, so together it is order n time. We reverse in place and use only a few pointers, so the extra space is order 1. Copying the values into a list would also work, but would cost order n space. 3 things. First, reversing the second half actually mutates the list. So if the caller needs the original order back, restore it afterwards. Second, we compare the values of the two halves, not the node objects. And third, the simplest approach is to copy values into an array and check that, but it costs order n extra space.